So we're going to be doing a video on calculus methods, level 2 calculus, and I'll be going over question 1 over the 2018 paper. So looking at the first question, we've got a function f, which is given by f of x is equal to x cubed minus 6x plus 2. So what we're going to do with this function is we're going to differentiate it. So first things first, we're going to differentiate this function, so f dash of x. And again, just remembering over here, each term, we take the exponent to the front, so we multiply it to the front, so we get 3 times x, and we subtract 1 from the power. So we get 3x squared. We do the exact same over here. So subtract 1 from the exponent, so we've got negative 6, and then the plus 2 disappears. Alright? Now we're told to find the gradient when x is equal to 4. So I can replace x with 4. So 3 times 4 squared minus 6, and therefore the answer for this, 4 squared is 16, so 3 times 16 is 48 minus 6. So the answer, or the gradient, when x is equal to 4 is 42. Alright, this is an achieved question. Moving on, we've got a rectangle which is expanding. Its length is 3 times its width. So what's really important is we'll draw a diagram. Okay, so first things first, I'll write a statement. So length is equal to 3 times the width. I'll draw a rectangle. Oh, that's a pretty bad rectangle. I'll try to draw a better one. There you go, that's a bit better, I guess. This is our width, and this is our length. And remember, length was equal to 3 times the width. So the area is equal to length times width, which is 3w squared. We're told to find the rate of change of the area of the rectangle with respect to its width when the area is 75 centimeters squared. So I need to find out what the width is first when the area is 75 centimeters squared. If I go 3w squared equals 75, I can actually rearrange and solve for w. So I divide both sides by 3. I'm left with w squared is equal to 25. I'll square root both sides. So I want the square root of 25. And remember, because it's a square root, we get two solutions. So therefore, I get w is equal to positive 5, or w is equal to negative 5. Now, because we're dealing with width or measurements, we can't really have a negative answer. So I stick with the positive answer. That's why, because we want positive measurements. So now I'm going to go find out what the rate of change is. Now, I'll draw a line between here. I'll actually go and differentiate. So I've got dA over dW, which is equal to 6W. I'll find the rate of change, so I'll substitute in 5 in there. So dA over dW is equal to 6 times 5. Therefore, dA over dW is equal to 30, and I can put units with this. The units for area is centimeters squared, and the units for width is centimeters, and I can write a statement saying the rate of change of area, so the rate of change of area is 30 centimeters squared per centimeter. Okay, when the area is 75 centimeters squared. So what we're saying is the rate of change, the area is changing at a rate of 30 centimeters squared per centimeter. That's what we're trying to say over here with rate of change. So that's question 2. If you get the rate of change correct, that's a merit question right there. Alright, moving on, we've got question C. So we're going to find the derivative of the function actually given. We're going to find the function, I'm not even reading this properly. Whoops. So the derivative of the function is given. The graph of the function has a local minimum, which is 0, 5. We're going to find the local maximum of the function. So we want to find the maximum. So we've got the minimum. Let's find the maximum. So first things first. Since I've been given the gradient function, and I've been given the minimum, I'm actually just going to make this function equal to 0 to find the maximum. Because remember, f dash of x must equal 0 for us to find our turning points. Because at our maximum or minimum, or at our turning point, the gradient is 0. So this is saying the gradient at our gradient is 0. So at our turning points, the gradient is 0. So I can just write down 0 equals negative 3x squared plus 12x. Alright. Now I'm going to factorize. So 0 equals, I'll take negative 3x out as a common factor. So I'm left with x minus 4. Now I'll solve. So x equals 0 or x is equal to 4. Now we know that this over here was our minimum. So therefore this over here is our maximum. Because we were told that that is our minimum right there. So now I've got the x value for the maximum, and I need to find the y coordinate. Now to find the y coordinate, we'll have to actually integrate our gradient function. So we've got 3x squared plus 12x. We're going to integrate that. So now we get our function f of x is equal to negative 3x cubed over 3 plus 12, oops, I forgot the x there, 12x squared over 2 plus c. Right, I'll draw a line here and I'll move over on this side now. So I can simplify this. So f of x is equal to negative x cubed plus 6x squared plus c. Now let's find c first. And we know for c, we were told that when x is equal to 0, y is equal to 5. So I can find my c. So I've got 0 cubed plus 6 times 0 squared plus c equals 5. Obviously I get c is equal to 5. Therefore my function is f of x is equal to negative x cubed plus 6x squared plus 5. Now I need to find my coordinate, so my y value for my turning point. I know the maximum is 4. So let's go find our y coordinate. So I substitute in 4 and for x. So this becomes negative 4 cubed. 4 cubed is 64, so that's negative 64. 4 squared is 16. 16 times 9 is 96. I should double check that actually. You know, it's never good to assume, right? Let's double check that just to be sure. Yep, oh, look at that. Good. Plus 5. We add it all up. So we've got 64 minus 96 plus 5. That becomes positive 37. So the maximum is at coordinate 4, 37. Right? So that's where our local maximum is. Now this again was a merit question. Cool. It is a bit of a process, but it's always good to show all your working. Alright? Cool. Moving on to the next question. Alright, so we're going to use calculus to find the values of x for which the graph of the function is increasing. So we want to find out where it's increasing. So the first things first, if we're trying to find out where the function is increasing, it's good to find out where the turning points are. So we'll find out our turning points. So we'll differentiate the function. So we got, 3 multiplied by 2 over 3x squared plus 2 multiplied by 9 over 2x minus 5. I can simplify that. So I'm left with 2x squared plus 9x minus 5. Oh, sorry, that's f dash of x. Now we want to find our turning points. So we know to find our turning points, f dash of x must equal 0. So the gradient must equal 0. So if I just replace this with 0 there, we've got 2x squared plus 9x minus 5. Now we need to factorize this. Now you can just use your graphics calculator if you want to factorize it. You can use the quadratic formula to find the roots. I'm just going to factorize it. Well, what am I saying? I'm going to factorize it. So 2 times negative 5 is negative 10. I'll draw it on the side here. Actually move over. give myself a bit more space. So 0 equals 2x squared plus 9x minus 5. I've done 2 times negative 5, which equals negative 10. Two numbers that multiply negative 10 but add to positive 9. That's pretty straightforward. 10 times negative 1 and 10 minus 1. So I can go 0 equals 2x squared plus 10x minus x minus 5. Factorize in groups. I'll take 2x out as a common factor for the first two terms. So I'm left with x plus 5. And I'll take negative 1 out as a common factor. I'm left with x plus 5. So I get x plus 5 and 2x minus 1 equals 0. So therefore I know the roots would be x is equal to negative 5 or x is equal to 1/2. So I can write this over here now. X is equal to positive or negative 5, sorry, or x is equal to 1/2. Alright, and now I need to determine which one is the maximum, which one is the minimum. So I use the second derivative test. So f double dash of x, I'll differentiate that again, so we get 4x plus 9. Substituting my two x values in one at a time to find out which one is my max and which one is my minimum. So I put in 1/2 first. So we get 2 plus 9, which is equal to 11. Now since f double dash of x, the second derivative is greater than 0, this is my minimum. Come on the side here. F double dash of, I'll put negative 5 in there, is equal to 4 times negative 5 plus 9, which equals to negative 20 plus 9, which equals to negative 11. So my second derivative is less than 0, so this is my max. Cool, so I found out what my max and my minimum turning points are, those x values. So I need to find out where it's increasing and decreasing. So I need a bit more space. Probably move over a bit. I'll just get rid of all this factorizing work over here on the side. So I give myself a bit more space. Cool. So we know, and I'll write on the side here as well so I can see it, max is at negative 5 and minimum is at positive 1/2. So if I roughly draw a set of axes, okay, negative 5 is around here somewhere, so this is where my maximum is, and 1/2 is about here, so this is my minimum. And I've got a cubic function. If you look at the original function, it's a cubic. We've got this over here to raise to the power of 3, so it's a cubic. So I can draw a rough graph. So we're looking at something along the lines of this. Here we go, look at that, it's pretty good. Right, now we need to find out where it's increasing. So the gradient is positive. Now the gradient is positive obviously before our maximum occurs. And it's positive after we reach our minimum. So after we go past our minimum, that's where it's positive. So we can actually use this graph to determine where our x values, or where it's increasing. So the function is increasing, so I can write on the side here. The function is increasing when x is less than negative 5 and x is greater than 1/2. So that is when our function is increasing, right? So that is how we do it. You can use a graphical way of showing evidence, or you can use a test. You can test other points around your maximum and minimum to show what the gradients are like. But I want to use a graphical example. So if you do this with an example, some kind of evidence, you get an excellence for that question right there. Okay, so finding the turning points or the maximum and minimum value, that gives you a merit, but then going and showing where the function is increasing and giving the range gives you an excellence. Cool. I think one of the last question of this part, or last question of question 1. So now we're looking at a rectangle which measures 10 by 8. There's a parallelogram inside, and we've been given all these values and we're saying that x is the same all around. We want to use calculus to find the smallest possible area of the parallelogram. So we need to justify our answer as a minimum. Okay, so we need to show some proof. So first things first, you have to come up with a function. Now the area of a parallelogram is pretty much length times width, or base times height. Base times height is probably the more common one. Right, so where this is the base, right, and this is the height. The height's not really, it's like on a 90 degree. So assuming that that's 90. But what I could do is, I'm not going to use this approach. I'm going to use a different approach. What I'm going to use is I want to use the whole rectangle, because I know the area of the big rectangle is 80, because 10 times 8 is 80. And I've got 4 triangles. And remember, this triangle over here is the same as that triangle over there. And this triangle over here is the same as this triangle over here. So I can just subtract off these triangles. So if I create an area function now, well, first things first, let's go and find out the area of these triangles. So this over here, this length is x. This length over here would be 8 minus x. Alright? We've got x over here, and this length over here would be 10 minus x, so we're subtracting x off. Now let's find the area of our yellow triangle. So area of the yellow triangle is half base times height, but I've got 2 of those. So 2 multiplied by half, the base we can say is x, and the height is 8 minus x. So I can simplify that. That leaves me with 8 bracket, or x bracket 8 minus x. The 2's cancel out. And the area of the blue triangles, again we've got 2 of those. We've got half base, we'll make our base x again. Oh, 10 minus x. Again the 2's cancel out, so the area of the blue is equal to x bracket 10 minus x. So these are my total areas. So I'm going to subtract off. So my area of my parallelogram is going to be taking the rectangle, which is 80, and subtracting off these 2 areas, or these triangles. So x bracket 8 minus x bracket 10 minus x. I can expand this out now. So I've got 80 minus 8x plus x squared minus 10x plus x squared. Now again, I get a function. I can simplify that, add all my like terms. So minus 18x plus 2x squared. Yes, I got a function on my parallelogram. Now I'm actually going to differentiate this because I want to find the smallest possible area. So dA over dx equals negative 18 plus 4x. Now because we want to find a minimum, we have to remember that our gradient function must equal 0, because at our maximum minimum turning points, the gradient is 0. So we will have negative 18 plus 4x is equal to 0. 4x is equal to 18. We're solving for x. Therefore, x is equal to 18 over 4, which is 9 over 2. 9 over 2. Right? Cool. And now, we're going to determine, well, is this actually a minimum? So what I could do is I can use a second derivative test, which I'll probably do. I'll use a second derivative test. I could use the idea of, well, this is a positive parabola because the value over here is positive, so it's a smiley face parabola, so therefore we only have a minimum. We could use that as a justification. I'll use a second derivative test because I like the second derivative test a lot. So I'll have d squared a over dx squared is equal to positive 4, and because the second derivative is greater than 0, therefore I have a minimum. Cool. Now let's go and find our area. Alright, so I'll just use this little box over here. I'll draw up a little box to give myself a bit more space. Now we know our x value, we know our function. Let's go and substitute it in. So we've got 80 minus 18 times 9 over 2 plus 2 times 9 over 2 squared. So we've got 80. So that becomes minus 18 times 9 over 2. 18 divided by 2 is negative 9. Negative 9 times negative 9. Negative 9 times positive 9 is negative 81. Alright, then I've got 9 over 2 squared. 9 over 2 squared is 81 over 4. So I'll just write it down. So 2 times 81 over 4. So if I've got negative 1 plus 81 over 2. 81 over 2 is 40.5. And because I'm subtracting 1, that becomes 39.5. So that's 39.5 centimeters squared. That is my minimum possible area. Right? So this over here is my minimum. Oops. Minimum possible area.